So, for today's video, we were going to tackle about the Newton's law. As we all know, the first law of Newton is the inertia. Inertia is the tendency of an object to resist changes in its velocity, whether in the motion or the motionless. Once an airborne unless acted by an unbalanced force, gravity and the air fluid friction, it would never stop. Unless acted upon by unbalanced force, this golf ball would sit the tree forever. Object on Earth, unlike the frictionless space on the moon travels through, are under the influence of friction. Friction. So what is friction? So there are the four main types of friction: sliding friction, rolling friction, fluid friction, air or liquid, static friction. Then, the second law. As we all know, the second law of the Newton's law is the acceleration. The acceleration proceeds by the net force acting on an object is directly proportional to the magnitude of the net force is in the same direction as the net force and inversely proportional to the mass of the object. As we all know, so I would going to show you some examples of pictures of the force. So as you can see, force is a push or pull that causes changes to the motion of an object. The gravity, force between an object, the electricity, force of the electrons, the magnetism, force of the field, and last, the friction. So, last, the third law. For every action, there is an equal and opposite reaction. According to the Newton, whenever the object A and B interact with each other, they exert forces upon each other. When you sit in the chair, your body exerts a downward force on the chair, and the chair exert upward force in your body. There are two forces resulting from each certain reaction, a force on a chair and a force on your body. These two forces are called action and reaction forces. So this is the main example of everyday life that we can use, or as we can see in the third law of Newton's law. So, Newton's third law in nature. As you can see in the picture, consider the proportion of the fish through the water A. Fish using its fins to push water backward. In turn, the water reacts by pushing the fish towards, propelling the fish through the water. The size of the force of the water equals the size of the fish and the direction of the force the water backwards in the opposite direction from the force on the first fish forward. So that would be all. Thank you for watching.